Okay. So we have our tile map data, and we want to sample from it. So we need some type of like do mapping function that takes from the tile map rather than from the canvas itself. So if we look at our code, we have this do mapping, and we have a canvas adapter, the source, and the destination. So having a source and destination, that's still good because maybe for our source, maybe we want the viewport to be letterboxed. So the viewport might actually be smaller than the canvas, right? Because like in a video game, right, you have that black letterboxing. So keeping a source rectangle and then a destination rectangle, right? That is going to be the selection area on the data set or the tile set that is off screen. So we do want to keep that, but it's just that instead of using a canvas adapter to sample from and do that mapping, we just want to swap that out for a tile map. And really we could just get working on that right now, because we could instead of copying this do mapping function, I just want to refactor it and just move on, right? So the first thing I'm going to do is a quick sanity check. I'm going to comment out this code, and I'm going to look at the screen and make sure I see what I expect to see. Okay, so that's what I expect to see because this is like the default pattern that we're filling our canvas with when we create it. So let's go back to here, and we're going to put the do mapping function back in. But instead of using the canvas adapter, we're going to... Well, technically we still... it would need like a do mapping and then like an apply. Let me think. Screen map. I guess technically the canvas is still going to sample. Well, we can adjust things as we go. Canvas adapter, and then the tile map. So the rec src takes from here, and then the rec dst puts here. Alright, so the idea is that we're going to take that source rectangle and we're going to read data off of the tile map, and then use that destination rectangle to map onto our canvas. So let's so we actually don't have a variable called, let's just do that right now. So var tile map, and then it was like globals something or other. Let me put a little breakpoint here. And then actually control, what is it, control shift 2? Or is it just control, God, I forgot what the remove breakpoints thing is. I think it's control F2. No, Control Shift F2? No. Control Shift Alt F2? Yes, Control Shift Alt F2 to remove all the breakpoints. Okay, so put that there, and I know the globals is at the very top. And it's, okay, I called it global map, and then, okay, so that's wrong, right? I don't wanna, this should be called tile map, right? Because it's tile map, and then this is on the inside. And create unit A tile map data. So we'll call this tile map like that, and then we're going to just call this create tile. I'm just going to call it create tile map. Okay, create tile map. Okay, so I'll take this global data dot tile map, go over here, global data dot tile map, right? Okay, and then that's the second parameter, and so do mapping. We're gonna take the tile map, put that in there. So we got the canvas of adapter, and then our tile map, and then the rectangles for the destination to the source. And then we can make a little summary here. Read data off of tile map using, and then write to canvas adapter using, right, just a little comment to let us know what we're doing. Alright, so the purpose of the destination rectangle and the source rectangle and the tile map and the canvas adapter. Okay, so we have that, and right now, if we do this, is it going to break, right? Because we haven't refactored it yet, but the signature lines up, right? Signature still lines up, so we should still have the same thing on screen if we refresh right now. And let's just have a sanity check here, make sure I didn't screw anything up. Okay, so that still is what it is expected because we only changed the function signature. Okay, so going back here, let's see, where is it sampling from, right? So it's really this get and put that we want to change, right? So the put pix is fine because it's the destination coordinates, but it's these sampling coordinates that we want to get pixels from the tile map. And do we really want to like do all of that inline, all of that code again, or do we want to make some type of utility function, you know, get pixels from tile map? Do mapping. Yeah, you know what, we're gonna just inline that again. And we want to try to just write it. Get pixels, SX, SY, RGB. Okay. So let's put a little breakpoint there and reference our code for converting this formula again. We're gonna take that again, and yep, we're just cutting and pasting all over the place. So right here, we're gonna take that and refactor this. So it's the tile map. Actually, so this is going to be RGB, right? Because we're putting the pixel and we need to get the pixel RGB. Okay, and then this is the tile map dot map U8A. Right, so right here. Oh, sorry. Okay, and then using those indices, and same thing as before, the width is the tile map dot map width, and then the number of components, tile map dot the map components per pixel. So we'll take this width, we'll put it into the formula there, we'll take the number of components per pixel, and we'll put it there. And are we good to go here? So are we getting the pixel? Does that look all right? Yeah, that looks about right. So, and then canvas adapter.apply, that is actually good there. Okay, so we'll give this a shot, and we'll see if we screwed up anything horribly, but I think that should be good. Okay, so we're over here, and we got nothing. So that's great. So what did we screw up? Put pix RGB. So the first thought is it's completely blank. So it's not even, I don't think it's even putting the pixels, and why is that? I think we made some type of syntax error. Map width of undefined. So that tile map is undefined. Really? Okay, so let's go into our code here. This is a do mapping function. Tile map is undefined for some reason. So we're gonna say add a little bit of code here. If not canvas adapter, and then we'll just throw, and I don't know. Sometimes I get sick of making error messages, so I'm just gonna do that. I just don't care, right? And then we can just do this. Put that there. Tile map. Just have some checks to make sure that those inputs have some integrity, right? And then I'll just do A, B, C, and D with the current date, you know. And if we want to be really specific, we can just say what the time is. I don't know, what time is it? 3 p.m. Alright, so the idea is just to, you know, have that error show up so it fails right away if something goes wrong, right? We'd rather have it fail we'd rather have it fail right up here rather than it fail later down here somewhere, right? Because the source of the problem is really we supplied some bad parameters to the function, so we'd rather validate that at the beginning because it's going to make it quicker to find problems. So let's go to here and let's refresh and see if the logic I added catches the problem. So if we go into our console, we see now it's my specific error message, and we have the letter B, which is the tile map. So the tile map is null for some reason, well, or null-like. So we see tile map global data.tile map, and I kind of have an idea of why that would be. So let's go back up here. Global data, tile map, create tile map. You would think that since this is, oh sorry, you would think that since this is up here that would be created first. Oh, you know what? It's because we're not returning it. We got this function that's supposed to return a tile map, but we don't return it. So we forgot to return the tile map. So put that right there, and now we should be good. And okay, yeah. So let's do that. And now if we go back to here and we refresh, we should be in a better situation. Refresh. And no, we're not. So looking at this, y is not defined. And okay, because we didn't, when we copied and pasted this formula, right now I can see that we're using SX and SY for our source, and these So this should this be the destination or the source X? Tile map. Okay. So we're putting the pixels at dx and dy, right, which is the destination. So this should definitely be, in this formula, that should be sx and sy. So let's go back to our code. And really quick, we can probably just look at global data to find the call site. Okay, so we're doing the mapping. And down here where we have the y and the x, that's going to be source y and source x. So taking this, just put a little s in front of that for source y, and then this is source x. Now if we go back here and we refresh, we should be okay. So refresh. Okay, so we got something here, right? So the destination is definitely in the correct spot, right? So we know that's working, but obviously this is not correct because we wanted to fill with that donut pattern, but we're not seeing it. So the question is, where did we screw up, right? Did we screw up when we filled the buffer with that donut pattern? Like, did we fill the wrong pattern? Or are we sampling incorrectly? Or are we doing both wrong, right? And that's the problem, right, with not having that intermediary step of checking to make sure that we were filling that off-screen buffer correctly. Because now we could potentially have two errors compounded, right? You have two errors, it's like exponentially harder to solve, right? So every time you compound an error, you add another exponent of difficulty to solving the problem. So you really want to make sure that when you screw up, it's one screw up at a time, because once they start layering on top of each other, it can become like a big headache to figure out what the hell you did wrong. So one way we can try to figure this out is we could simplify the fill pattern to something that just like a solid color of something. So that way the logic is like dead simple and we know we probably didn't screw it up. That would be one way to try to eliminate one of the possibilities of where we screwed up. So this fill tile map with test pattern, we can go over there and we can take a look at it. And yeah, there's a lot of crap going on, right? It's like blah, 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 a lot of stuff. Right, this bounding rectangle, right? There's all this stuff. And you know what? I think this is way too complicated, right? Because I get that, we used a complicated pattern because we wanted to make sure that our viewport sampling transformations were correct from earlier. But I think maybe this pattern is just overkill. And what we should do is we're going to just rip out where we're actually accessing that data. And then we're just going to blow all of this away. And we're going to simplify. And instead of doing this, technically we do need a little bit of trickery here, because if we get the alpha channel to something besides 255, things could end up invisible, and we don't want that. But we could just say, you could say 32, 64, and 128. So it's going to be the highest color value is 128, and that is red, green, blue. So it's going to be a blue color that is, it's going to be a mostly blue color. that has become slightly muted. And then as far as what this index is, right, we have 4 components, right? That's why we have 0, 1, 2, and 3. So we're going to have var dex min, and that will be 0. Or actually, do you want to do that? Var number of pixels equals the tile map dot map width times the tile map dot map height times the number of components. And then I'm just gonna format it a little bit nicer. Times the tile map dot number of components. Or, well, no, actually, no, we don't times by the number of components because we just want the pixels. So width times height, basically, right? So the number of pixels, and we want to go through every single pixel. So for var, we'll call it pixel dex for pixel index equals 0, and then the pixel dex is less than the number of pixels, right? Because the first index starts at 0, and then pix dex plus plus. And then what we want to do is we have like a first component index. So var dex equals the pixel dex times the tile map dot map components. So, right, so there's 4 bytes per pixel, and we're going to times it by the index of the pixel, and that's going to give us the index of the first component. So this dex will always be, since it's ARGB, this is always, oh wait, is it ARGB or is it RGBA? I've been doing it this way, so I think so it's actually R, G, B, and A. So right, so this index always points at the red component of the pixel. Now this formula is not going to be valid if these map components is not 4, so we can like have some type of assert, like if actually we probably shouldn't do it out there. We should probably put it over here, like if map component is not equal to 4, we'll just throw a little error, throw logic coded for 4 components per pixel, right? So just a little warning that if that is not 4, our logic is completely incorrect. You know, because we did add that flexibility in, so we want to make sure we're not, rather than try to make this super flexible and just support different numbers, it's better just to do this and move on. Because chances are we're probably never going to make this number of components not 4. So this is a better solution than trying to support a number not equal to 4 and like taking all the time to code all that extra support. Okay, so we're going through every single pixel, and we're getting the index to the red, and then we can offset by 0, gets us the red, gets us the green if we offset by 1, etc. Okay, so that's like just a flat fill, right? And that's going to help us because if our, well, let's just see what that looks like. So this is dead simple enough where, you know, I'm just assuming that the test pattern is going to be correct, and that if we don't see anything correct on screen, you know, hopefully this will help. So let's refresh. Okay, so we see kind of a half and half thing going on here. So that tells me something is like kind of misaligned here, right? Because I thought we filled the entire map, yet it's kind of like we only see half. So what's up with that? So we are going through. Are we going through every single pixel? Yes, we are. One way this could happen. So another way we could do this. Let's try to make the fill pattern maybe a little bit more complicated to help give us a little bit more feedback here. Maybe we'll increase. Let me think. We could like make little scan lines where the color. Nah. Okay, so let's add like a little index to XY calculation here. So since this loop is dead simple, we absolutely know we're iterating over every single pixel. That's kind of why I did that. But let's do like a index to XY formula. Really? So let's we'll have to refactor some C99 code. So the pixel index, which is this guy. So the pixel index times the map width. So the tile map dot map width, and then you know what? We're just gonna say width equals tile map dot map width, and make these variables. Okay, the pixel dex, and then px, py, so pixel x, pixel y, the width of the map. Right, so now that we know the pixel xy coordinates, we can kind of like color based on that. And we can do something like really simple. So maybe like var r for red equals the pixel x value modulus, 256. Red, green, blue, green and blue. Y, and then sometimes I just do like px plus py, and then modulate it like that. And we'll just do something like that. Okay, so now we have a slightly more complicated pattern for filling, and we'll just plop that in right here. And also, we could actually just make, instead of doing that, I'm going to use a solid color here. So we'll still have that solid rectangle of blue, but then we'll have like some other information with these other channels to kind of like see what's going on here. So I'm going to take the blue, and we use like 128 for that, I believe. So 128, let's keep it at 128. And red, green, blue. Okay, so have that, and let's go look at the screen, refresh, see what's going on now. Okay, so that's interesting. We have filled it with what should be a gradient, but we're getting a solid color. So going back to the code here, let's make absolutely sure that we have a gradient, right? So get rid of the solid thing. I'm pretty sure we have a gradient, but let's do px plus py, and then, modulate that by 256. Okay, and then we'll go back to the top screen, and we'll refresh. And, I don't know, that might be a gradient. I gotta move this to some other monitors and see what I have here. No, that is not a gradient. That's like one solid pixel. So something is wrong with our mapping, and we're definitely going to the right destination, so that's good. But I think the fill pattern, we've simplified it. I'm pretty sure this fill pattern is working correctly. So let's try to figure out. Well, I'm gonna stop recording and start recording again.